In this video, we're going to find the interval of convergence of the following power series. So, just like doing the radius of convergence, we start with our ratio test, limit as n goes to infinity, of basically a sub n plus 1. So we put in n plus 1 any place we have an n, and don't forget your parentheses, times the reciprocal of a sub n. And then we're going to see what kind of simplifying we can do here. So we're going to rewrite those exponents, and we'll also rewrite the factorials a little bit. So first off, this is going to be x. Distributing that 2 will give us to the 2n plus 2 plus another 1, so plus 3, n factorial on top. This can be rewritten as n plus 1 times n factorial, x to the 2n plus 1 on bottom. So we have the limit as n goes to infinity. We can already see clearly one of our cancels, the n factorials. Now here, I have 2 more x's on top than I do on bottom. So when these cancel, I'll get left with an x squared. Now that x squared, if we want, we can actually pull it out in front of the limit. And normally let's just rewrite this all together. We can pull out the x squared. We don't need an absolute value because x squared is already going to be positive. So the limit as n goes to infinity, and all that's left is 1 over n plus 1. And this is a familiar one because we know as the denominator grows and the numerator doesn't, this is going to go to 0, which makes this 0, which is always going to be less than 1, which means our radius of convergence is infinity and our interval of convergence is negative infinity to infinity. This is our favorite case because that means our power series converges for all values of x.